Welcome back to ThinQa. Did you know that the same 3D model can look completely different depending on the printing method used? In today's video, we'll compare three of the most popular 3D printing technologies: FDM, SLA, and SLS. Let's explore how these technologies work and when to use each one. First, we have FDM, or Fused Deposition Modeling. This is the most widely used type of 3D printing, especially for desktop 3D printers. In FDM printing, a plastic filament is heated until it melts and is then extruded through a nozzle. The printer deposits the material layer by layer, gradually building the object from the bottom up. The most common filaments used in FDM printing include PLA, ABS, PETG, and nylon, each offering different properties such as strength, flexibility, and heat resistance. One of the main advantages of FDM printing is its low cost. Both the printers and materials are relatively affordable. It is also easy to use, which makes it ideal for beginners and rapid prototyping. However, FDM prints often show visible layer lines, which can affect surface quality. In addition, the level of detail is usually lower compared to other technologies. Next, we have SLA, or stereolithography. This 3D printing method uses a laser to cure liquid resin, turning it layer by layer into a solid object. The result is exceptionally high detail, with smooth, professional quality surfaces. One of the biggest advantages of SLA is its very high resolution and smooth surface quality. The laser can cure extremely thin layers, allowing the printer to produce fine details and precise geometries. This makes SLA especially useful when working with biomimicry designs, where structures are often inspired by nature. Many natural forms, such as leaf patterns, shells, or other complex natural geometries, contain very small and detailed features. SLA printing allows these details to be reproduced with high accuracy. However, unlike FDM, SLA prints require post-processing. This usually involves washing the printed part to remove excess resin and then curing it under UV light to achieve its full strength. Finally, we have SLS, or selective laser sintering. This technology uses a laser to fuse powdered material, usually nylon, layer by layer to create the final part. One major advantage of SLS printing is that it does not require support structures, because the surrounding powder supports the part during printing, which makes SLS widely used in engineering and industrial applications. For example, SLS can produce functional mechanical components, lightweight lattice structures, and complex internal channels. However, SLS printers are typically more expensive, and the printed parts usually have a slightly rough surface finish. In this video, we explored three major 3D printing technologies: FDM, SLA, and SLS. Each technology has its own advantages and is suited for different applications. FDM is affordable and widely used for rapid prototyping. SLA provides very high detail and smooth surface finishes. And SLS enables strong parts and complex geometries for engineering applications. Choosing the right printing method depends on your design requirements, material properties, and final application. Thank you for watching, and stay tuned for more tutorials on AI-driven design and digital manufacturing with ThinQa.